This is Project 2 for ECE452, Spring 2020. Our challenge for this project was to have a robot that is capable of going from its initial point, which is origin 0, 0, to a selected point of our choosing. We are using Linux Ubuntu version 16, and we have the ROS, or Robotic Operating System, installed, as well as using Gazebo for simulating this project. To my left here is where the Python code is, and here we go over just a setup of the entire system and everything like that. So starting from the top, we initialize where our location is, and then we import all our necessary libraries and equations. So for example, math, we import our arctangent and our square root. And then we have our global variables set here. These were given, and these are going to be used a little bit later on. And then here we have class odom reader, and what the odometer is just the turtlebot burger telling us its data. So it's the data that is referencing off of the device itself, and we use this a little bit down below here to do comparisons. So next we have our main, there's a main loop here where we have a node where it's to go to the point, and then we also have a shutdown. This is once the node is terminated, and then we also have the DOM variable, and then we also have the sleep, and we also have the publisher set up here as well, and this is just grabbing stuff from our file system. And then down here below everything is our point, our goal. So we can set this to any values we want. So in this case, I have it set to 0.5 and negative 0.75, and that's where the robot should go to, and we're currently at 0, 0. So below here is a bunch of variables and equations that we were supposed to set up. So first here we have our x and y position, in which it is referenced with our goal, which we select, subtracted from the odom x and y, and that is where the robot is. So we take the difference of those two, and we actually know how far, in fact, in the x and y direction does the robot have to still travel. Next, we have to find the angle to the goal. So we take the arctan of our x and y variable, that is the combination of both our goal and our difference. So it's the difference put together in there. And what this is really going to do is pretty much just rotate the robot until we are within the we're facing the right direction. Then we need to calculate the difference of the two angles, of the one where we calculate the goal angle, as well as the one that is being read off of the robot itself at that time. Next, we have the distance formula. This is just that we know how far away we are from our goal. And then we will go to our actual code. So we have an if statement where we say if our angle to goal minus our angle being read directly off of the robot is greater than 0.1, that then the robot should not move linearly, but it should rotate this way so it can orient itself in the correct direction. Then I do two else if statements, and with two different setups. The first one being the distance difference is greater than 0.1, meaning we are further than 0.1 away from our target. And with that, I tell it to keep the speed of its linear axes 0.5, and then to not rotate in this case. And then I make another else if statement where if it is 0.1 or less in terms of the goal in which we're trying to reach, we then terminate this. And I had troubles actually terminating this properly, so I actually errored out with just an undefined variable. In this case, it's time. So what will happen is the robot will go through its whole process, and then once it is within the range, it'll go through this else if loop and immediately get kicked out and terminate the program because of undefined variable. I just had some issues with that, so this is the route I chose. Now that we went over the code, I'm going to hit save here and close it. So now we can actually run the code. So I'm going to hit up. And right here, we're going to do ROS run project _2, go to point3.py. This is the third version of the code. So I'm going to hit enter, and what we should see on the right where the robot is how it moves from origin to the top. As we can see here that we also have variable outputs here. It's telling me my x, y, theta, angle difference, and distance difference variables live. So what we're going to see here is the robot's going to spin around, and once it locates the correct direction, it's going to go in that direction and then spin around again and continuously do this until it reaches this final destination. And if we want to, in the code, we could also change the speed in which it rotates and its linear axes. So that's a simple fix that can be done. So you can optimize it to, maybe spin around a bit faster, but maybe not move forward as quickly, just to help improve accuracy, so that it gets within the range that it wants. But currently, I'm doing 3 for its linear movements and 0.3 for its rotation, I believe, and that seems to be doing pretty well. So we can see that we're approaching our positions of x equals 0.5 and y equals negative 0.75. So it should be a couple more seconds, and we should hopefully arrive to that final position. And as you can see, it reached its final position, and it was within 0.1 of both the X and Y, and it errors out and terminates the program, so now the robot is sitting there. Thank you for seeing how the project was completed. If you have any questions, feel free to comment below in the video, and I'll see you guys later.